in this lecture, we're going to be talking about two very important rules in probability. The first rule is called the multiplication rule. And no, this does not have to do with when do you multiply probabilities. This actually has a lot to do with conditional probabilities. So this is called the multiplication rule. And basically what it says is that if you want to compute a conditional probability, so say you want to find what is the probability of A given that B has already happened, this is the formula for how to compute this. It's the probability of A and B divided by the probability of B. Now, the only way I can explain this is if I were to use Venn diagrams. And I know I've mentioned how I prefer probability rectangles over Venn diagrams, but if I were to do a probability rectangles explanation in this lecture, it would actually take a great amount of time to explain this rule here. So I'm going to use Venn diagrams instead to basically explain this. Let's do a better circle than that. So, and in fact, let's use a different color here. Let's use blue, sure. So you have one circle here, this is A, this is B. And we're trying to figure out what is the probability of A given that B has already happened. Well, if B has already happened, then the only possible realm that we can be in within this Venn diagram is this area right here, B. So this is B. That's the only possibility that we have right now. So in theory, what I should be doing is I should be erasing this portion and only drawing that portion. Because this right here is the only A that can happen at this point because B has already happened. And if we want to calculate that region, it's the probability of A divided by the entire possible events, which is the probability of B. So this is not necessarily A though. This is actually, if you remember, this region is the probability of A and B. So it's important to understand that to figure out what this probability of A, given that B has already happened, is the probability of A and B divided by the total possibilities, the probability of B. And so that's my visual explanation of how this formula works. Most people, though, they don't need to memorize or understand this conceptually. They can just use this formula and it will work throughout their probability class. Now, the next rule is the addition rule. And this doesn't have to do with conditional probability. This actually has to do with double counting. So this is the addition rule. What does the addition rule state? Well, the idea is if I want to find the probability of A or B, this is just the probability of A plus the probability of B minus the probability of A and B. And again, this can only really be shown through Venn diagrams. So I'm going to draw a picture for you guys to show you what this means. Let's make this a little bit more fine. There we go. So let's say I have two circles, A and B. And I'm trying to find the probability of A or B, which happens to be this entire region. These are all the options that would satisfy A or B, this entire region. Not anywhere outside, not this region, but this entire region inside here. And so in theory, it's this region plus this region plus this region. And so let's figure out how we can figure out that. Let's find a way of adding up all those areas. Well, what I could do is I can find the probability of A, which is, let's use a different color here, purple. I could find the probability of A, which corresponds to that region. And then I could find the probability of B. But if you notice, there's a little bit of a problem here. It's actually this region right here because that area was double counted. That region was double counted in both the probability of A and the probability of B. And therefore, I need to take away just one of them. I don't need to take away both of the colors, purple and orange. I just need to take away one of them, which is why we subtract just one probability of A and B. Anyways, I hope this helps. Thank you guys so much, and I'll see you in the next lecture.